So solving a system using the substitution or elimination technique, we're going to look at the equation y equals x squared plus 3 and the equation x squared plus y squared equals 9. Now when I want to use the elimination technique, I can only think about eliminating terms that are the same power, and they also need to be on the same side of the equal sign. So I'm going to bring this x squared term to the left, which changes it to a negative. And what I'm going to notice now is that I have the x squared term that I can add together, and they will cancel. So I'm going to eliminate that particular variable. And so when I add my equations together, I have to remember these are unlike terms, so I'm going to write these in descending order. And then I'm going to move that 12 over so that way I can factor. So when I factor, I need to use the positive 4 and negative 3 factors. So that way they multiply to be negative 12 and add up to be a positive 1. So in this case, either y equals 3 or y equals negative 4. And so what I need to do now is I need to find the x values that correspond to that. And so if I check what happens when y equals 3, I'm going to plug that in over here, and I'm going to get 3 equals x squared plus 3. So when I move my 3 over, I get x squared equals 0. And that's fine, that happens. If I take the square root, I just get x equals 0. So one of my solutions to my system is going to be the ordered pair 0, 3. Now I need to check what happens with this other coordinate, y equals negative 4. And I'm going to get negative 4 equals x squared plus 3. But when I move the 3 over, I get a negative. So the problem is that even though we've talked about taking the square roots of negatives, in terms of solutions to equations, this is going to end up being a non-real solution, which means we can't use it. So you can't have solutions that have an I in them. And so this is going to get thrown away, and this is going to end up being our only solution. And the reason for that is that if we were to graph these two, what we would get is we would get a circle with a parabola that touches at one point and jumps right off. And so this is really the only solution to that equation. And I'm going to start writing my solutions since I'm running out of space. So I actually again have two solutions to this with the parabola and the circle. When x equals negative 2, or sorry, when x equals root 5 and y equals negative 2, but also when x equals the negative root 5, y equals negative 2. And then I'm going to need to check